Antidifferentiation. We've learned about differentiation. And today we look into the antidifferentiation of polynomials. So let's recall, if we have x in the power of n, what is the derivative of x in the power of n?
nx minus to the power of n minus 1.
nx n minus 1.
That's nice.
Now, finding antiderivative is doing the inverse operation. If we know the function f dash of x, what derivative function equal, then we look at how to find which function was differentiated to get this derivative function. So it's an inverse operation to differentiation. And today we're looking only into the differentiation, antidifferentiation of the polynomials, so power function. And let's have a look into the pattern. Maybe we will see how to do it. If we have the x squared, derivative of x squared equals 2x. Derivative of x cubed
3x squared.
3x squared. The derivative of x in the power of 4.
4x cubed.
4. So, antidifferentiation denoted with such sign called integral. And for example, as 2x is the derivative of x squared, then antiderivative of 2x, and notation we write always dx. Make sure that you write proper notation. If you don't write dx, you lose it. And so as we got 2x deriving x squared, so when we look in anti-deriving, we find what was derived. So it will be equal
X squared.
x squared. So antiderivative of 3x squared dx will be x cubed. Now, let's rearrange this one. But before this, we need to remember that we always, when we're anti-deriving, we add plus c. Plus c. Why we adding this plus c? Yes.
Because if there's no x value to the coefficient, to the c value,
Yeah.
then they just equal 0.
When derivative equals 0, yes.
Yeah.
Because if we derive, for example, x squared, derivative equals 2x. If we derive x squared plus 3, still derivative 2x, because derivative of 3 is 0. If we derive x squared minus 71, still 2x. So we don't know was any number in the function, because after differentiation, derivative of the constant is 0. So we always need to add this arbitrary constant c. If we will have, and in many cases we will have additional information which allows us to find that c and find particular function. This is a general solution, we can find particular function. Now, as it was with the differentiation, when we derive, for example, 5x squared, we could take 5 out of the derivative. Constant factor we could take out of the derivative. Same thing with the antiderivative. So let's take this, consider this, and take first 2 out. And we will have the 2 times antiderivative of x dx equals x squared. And so antiderivative of x dx equals x squared over 2. Make sense?
Yeah.
I just take 2 out of the antiderivative and move it to other side. This constant factor can be taken out of the antiderivative, out of the derivative. Doing the same thing with this, we can get that antiderivative of x squared dx will be equal x cubed on 3
Plus A.
plus c, yes. But can you see the pattern?
Ah, yeah.
Yes.
We have 1 power 1 here. What happens with when we derive,
Plus
power
one,
drop by
over
1.
two.
When we anti-derive, power increased by 1. But also, we dividing by the same number. So general formula for anti-differentiation of the power function is antiderivative of x in the power n dx equal x in the power n plus 1 divided by n plus 1 plus c. This is a formula for anti-differentiation power function. So for example, if we want to anti-derive x in negative 3 dx.
It would be x to the power of negative 2 on negative 2.
Excellent.
Hear that, camera? Yeah.
And
Nice.
plus c.
Plus
And
C.
plus c.
Instead of
Yes,
c.
very good. So it will be x in negative 2 over negative 2. If we need to anti-derive x in the power,
8.
let's say 3 on 2 dx.
Nah, Steve's doing that one.
X to the
Power of
5 on 2
over a half.
negative, no.
No.
Over 5 on 2,
Plus
which becomes
Plus c.
2x in the power 5 on 2 over 5 plus c.
What if the coefficient of x is greater than 1?
If coefficient of x is not 1, not necessarily greater,
Oh, yeah.
smaller, constant factor we can take out of the antiderivative. So if we have antiderivative of a times f of x dx, it will be equal a times antiderivative of f of x dx. Whatever is constant factor, we can take it out of the antiderivative. Another rule for
So
anti-differentiation.
can we do that one with a number though? Just to get my head around it.
Okay, if we have 5x cube, probably not cube, let's say 5x in the power of 4 dx.
Equals 5.
We take 5 out,
So we
now
combine.
x in which power?
5.
5 over
5.
5.
So that's the answer.
Plus C.
So it will be x in the power of 5 plus c.
Oh, because you cancel out the 5.
5 and 5 cancel out. I intentionally take number that will cancel out.
Alright, buddy.
Now, if we anti-derive sum or difference of two functions, f of x plus or minus g of x dx, and I will say, put brackets. Your textbook doesn't put, or not always put the brackets around. If it's dx, at the end it relates to whole thing. It will be equal antiderivative of f of x dx plus or minus, depends what sign was there, antiderivative of g of x dx. So antiderivative of the sum or difference equals sum or difference of the antiderivatives. Make sense?
Yep.
And one more thing, finding particular solution. If you need to find function, if you have antiderivative of x in the power, let's say x squared dx, which need to find particular solution, which going through the point, let's say 2, 5. So function going through the point 2, 5. What the antiderivative of x squared dx?
X squared dx will be It's pretty simple, it's just x cubed.
On 3.
On 3.
On
Plus
3 plus c.
You can't forget about plus c because
Now,
So the
if we have
derivative
substituting point, so we have 5
equal
y value equal 2
Eight.
cube over 3 plus c. So we have c will be equal 5 minus 8 third equal
7 thirds.
7 third. So in this case we got particular solution y equal x cube on 3 plus 7 on 3. Make sense?
Yes.
So when we have extra bit of information, we find general solution, and when we substitute point to find c for that
Wait.
particular function.
So what that's doing
Is
is
the water even good?
finding where, at what point, at what y-intercept that gradient.
Not y-intercept. When we find antiderivative function, for example, we found that our antiderivative function is quadratic, but it can be any of those quadratics because plus c can move it up or down.
Yeah, but it's
Any of them, it's infinitely many solutions. When we have one particular point,
oh yeah.
let's say we know this point,
Cas-
that makes out of all infinitely many
Where
translated solutions,
Ah, okay.
we get one particular solution. That's given point, like nail the one required solution.
But you're finding it from a gradient.
Finding
From the
it.
derivative, from the gradient graph.
No.
Because you're using the gradient
No.
of that graph to find.
Yeah, when we have a gradient function, which is derivative function, from which we found
Oh, yeah.
antiderivative function, and using extra information, we found if we have any,
Yeah.
which one is. Note, if question says find an antiderivative, not just find antiderivative, says an antiderivative. If it has this, that indicates that plus c is not compulsory. You still can add plus c, you will not lose mark, but you don't have, if you have prefix n in front of the word antiderivative, you don't have to add plus c. Okay, that's new theory for today, and we'll do now some practice.